So welcome. Today we'll be looking at binary operation. So our objective is to know how to define binary operation, state the properties of binary operation, find the identity element of a binary operation, and finally find the inverse element of a binary operation. Okay, now let's look at the definition. Okay. Binary operation is a rule for combining elements to produce another element. In addition, for instance, addition, subtraction, multiplication are common binary operation in mathematics. So, we normally combine numbers using addition, multiplication, division. So, but in this case, we are going to be looking at different operation now. So what they will do, will be given an operation, and the operation will be defined. So from that definition, you can now solve whatever you are asked to solve. So let's look at this first example. They said a binary operation asterisk is defined by a asterisk b equals a plus b minus ab over 2. We're asked to find the following. So like this, now we are given an operation asterisk and is defined by this. So a is any number, the first number, like for a, our first number is 2, while b is 5. So 2 star 5, a is 2 and b is 5. So you will have 2 plus 5 minus 2 times 5 over 2. So our answer is 7 minus 10 is minus 3. So we'll have minus 3 over 2. So that's the answer for A. While for B, we have to find 7 asterisk minus 3. Also, A is 7 here and B is minus 3. So I have 7 plus minus 3 minus 7 times minus 3 over 2. So I have 7 minus 3 is 4. 4 plus 7 times minus 3 is minus 21 times minus 1, which is plus 21. So over 2. So we have 25 over 2. So let's look at the last one. We have 4 asterisk 8. That's the C. The last one is now 4 plus 8 minus 4 times 8 over 2. So I have 12 minus 32 over 2. So this is 12 minus 32 is minus 20 over 2. So we have minus 10. So that's it. So look at the second question. They say the binary operation triangle. So in this case, they always give you the operation and define. So before they will now ask you questions. So we have A triangle B is now A raised to power B. So whatever that is here, we'll raise this once it's A triangle B. So they said if A triangle 2 is 12 minus A, we asked to find the possible values of A. Okay. So they told us that A triangle 2 is 12 minus A. But from our definition, A triangle B is A raised to power B. So I have A raised to power 2. Because my A is A, but my B is 2. Equals 12 minus 8. So this will lead us to quadratic equation. A plus A minus 12 equal to 0. And if you check the factors, I have a plus 4 times a minus 3 equal to 0. So you know, for product to be 0 means that one of the numbers must be 0. So either a plus 4 is 0 or a minus 3 is 0. Therefore a, or which implies that a is minus 4 or a is 3. So our answer is minus 4, 3, so option A. So that's it. So let's look at the properties of a binary operation. So the first property is closed property. A non-empty set X is closed under a binary operation triangle. So in this operation we are just using triangle. So any other operation, it depends, but in my own notes I use triangle. If for all A, B are element of the set, then A triangle B is an element of X. So this is just like, this is just like you are given two elements that will combine under a certain binary operation. So note that whenever the combination is done, it must give us a value that is within the set. So example now, assuming we have a set of numbers, maybe 1, 2, 3, 4. So, and I now combine this by an operation, maybe star, A star B is now A plus B. So if I combine this and the answer that you get is not within this set, it means that it's not closed. Like example, if I now do 1 star 2, which is 1 plus 2, my answer is 3. 3 is inside the set, is part of the set, so this is closed. 1 star 2 is closed. So that's it. But if I do 1 star 4, the answer is 5. And 5 is not within the set, so it's not closed. So it's just like a boundary. So that's the meaning, closure. So not every number will satisfy that. So the numbers that once the combination is done, it must be either 1, 2, 3, 4 for it to be closed. So that's the meaning. Coming to commutative property. So they say given non-empty set which is closed, so it must be closed under a binary operation triangle. I told you can use any other operation, but I'm using triangle. If for all A, B is an element of S, then A triangle B must be B triangle A. So we are saying that if you have an operation, and remember it must be closed, and if you operate A triangle B, it will be the same answer as B triangle A. That's the commutative law. It's like 2 plus 4 will also give us 4 plus 2, which is 6. So that's the meaning of commutative. So generally, mathematics, addition and multiplication is always commutative. So associative. So they say given a non-empty set X which is closed under a binary operation, if for all A, B element of the set, then A triangle B triangle C must give us A triangle B triangle C. So what we are saying here is that if you are given 3 sets now, so if you decide to combine 2 before the third one, it will be the same thing as combining the other 2. So example now, we know that assuming we have, let me use addition, we have 2 plus 3 plus 4. So if I decide to do 3 plus 4, this is 2 plus 7. So the answer is 9. Or if I decide to do the same operation, 2 plus 3 plus 4. So I decide to do 2 plus 3 first, which is 5 plus 4. It will give me 9. So that's the meaning of associative. So it doesn't matter the one that you start first. It will still give you the answer. And what was the so you need to be conscious here, because they must have the same operation, triangle for it to be the same answer. But look at distributive. Distributive will combine two different operations. Like they said, given a non-empty set which is closed, remember they must be closed, under a binary operation, triangle and star and asterisk. So the two operations here are triangle and asterisk. If for all A, B, the all element of the set, then A star B triangle C. That is, if you combine B triangle C, and after you now combine A star that, it will still give you the same as combining A star B. You keep it, combine A star C, you keep it, after you now find A star B triangle A star C. That's the meaning. So let me just use our basic knowledge. Assuming we know that, assuming you are given 2 brackets 3 plus 4, you know, for us to solve this is the same as 2 times 4. You know, this is the operation here is multiplication. So I have 2 operations, multiplication and addition. So it's the same thing as doing 2 times 3, then you add it to 2 times 4. That's the meaning. That's just the meaning. The star here is like multiplication, while the triangle is like addition. So do you see it's 2 star B? So this 2 is A, B is 3, and C is 4. So that's the meaning of distributive law. So you must have 2 different operations. So that's it. So let's look at this question. They said an operation triangle is defined on the set of R of real numbers by this. So our operation is this. For all A, B, the element of real numbers. So they now ask us, is the operation commutative? Is the operation associative? So let's test. We remember that for any event to be, we know that for any operation to be commutative, that A triangle B must be the same as B triangle A. So they must give us the same answer. So I will solve the two and know whether we'll get the same answer. So let's start with, okay, they have given us A triangle B. So let's do B triangle A. So no need of wasting time. So we now swap B plus A minus B times A over 3, which is the same thing as this. A plus B minus AB over 3, which is A triangle B. So the answer is what? Yes, it is commutative. So that's our answer. So they now ask us whether it is associative. So we now introduce a third, let's introduce a third element. Let's call it, let's C be an element of the, okay, real number. So let's C be another number on the set. Then if A triangle B triangle C, that is after solving A triangle B triangle, that's after solving B triangle C and combine it with A triangle, it will give us the same as A triangle B first. So it will give us the same thing as A triangle B, then we'll combine it with C. So let's try. Let's start with the first one. Let's do A triangle. Let's do this. So first we get, okay, we have A triangle B triangle C is now B plus C minus BC over 3. Yes. So which is equal to, I'm solving the left hand side. This is now one term. So A triangle this now is, we have A plus B plus C minus BC over 3, over 3. Do you get? So all these things here is like b. So let's do the left hand side. So we have a triangle, this b triangle c is now b plus c minus bc over 3. So that's it. Let's continue. So if we are combining a triangle, all this, so this is now a plus b plus c minus bc over 3 minus a times b plus c minus bc over 3. So after everything divided by 3. There's no space, so I have to write it this way. So divided by 3. So let's move to the other page. So multiply both the numerator and the denominator by 3. So 3 times a is 3a. 3 times this is b plus c minus bc minus 3 times this is a bracket b plus c minus bc, and 3 times 3 is 9, that's over 9. So okay, maybe let's open up for the last time. We have 3a plus b plus c minus bc minus ab minus ac plus abc over 9. So we've done this. Let's check the other one. The right hand side. So we are doing a triangle b after triangle c, and we know that a triangle b is this. So I'll just write direct that a so we have a triangle b after triangle c, and we know that a triangle b is a plus b minus ab over 3 triangle c, which is equal to a plus b minus ab over 3 plus c minus a plus b minus ab over 3 times c over 3. So multiply both sides, both the numerator and the denominator by 3. So 3 times this, I have a plus b minus ab plus 3 times c is 3c. 3 times this, that's all. So we're left with c times all this. I have minus ac minus ab plus minus bc, that's cb, sorry, this should be c, minus cb plus abc over 3 times 3 is 9. So let's check whether they are the same. So I have 3c here. Let's check whether there is 3c. So as you can see, there is nothing like 3c in the numerator. So, and also here is 3a. There is nothing like 3a here. So therefore, it is not associative. So it's associative if the left hand side is equal to the right hand side. So let's look at the question, the other question.